Good morning, friends. In the last lecture, we have discussed about the electromagnetic inductions and Faraday's law of electromagnetic inductions, and then the Faraday's first law and Faraday's second law of the electromagnetic inductions. Afterwards, we have discussed about the nature of induced EMFs. In this lecture, we are going to discuss about the induced EMF, that is the statically induced EMF and dynamically induced EMF. So the nature of induced EMF, that is the if the flux linkages with the conductor changes due to the either magnet moment or due to the coil moment, and EMF is get induced, means there should be a relative motion, either a magnet motion or the coil motion. So there are the three conditions we have discussed in the last lecture. There should be a conductor and a magnet or magnetic field, and third is there should be a relative motion between conductor and magnetic field. Then there is a inducing the EMF into that coil. So the nature of that induced EMF, okay, if the flux linkages with conductor changes due to either magnet moment or due to the coil movement, and the EMF is get induced into that coil. The change in flux linkages can be practically obtained by dynamically induced EMF or statically induced EMF. These are the two methods by which we can obtain the change in the flux linkages. Okay, so one by one we will discuss, that is the dynamically induced EMF and statically induced EMF. With the help of these two methods, we can achieve the change in the flux linkages. Okay, so one by one we will discuss. First is the dynamically induced EMF. So what is meant by dynamically induced EMF? An EMF induced due to a physical movement of either conductor or magnet. So in case of dynamically induced EMF, there is an actual physical movement of a coil or conductor. Okay, so how can it is obtained? We can see, consider a conductor of length L is placed in the magnetic field produced by the permanent magnet. See here, there are N and S pole, means this is a permanent magnet. In the permanent magnet, the coil having length L is placed, okay, and the magnetic is field from the N to S pole. These are the magnetic line of flux, and this coil is connected through the commutator to the voltage. Okay, this is a DC generator principle, which is based upon the dynamically induced EMF. So see here, the rotation of coil. If the coil is rotated in the magnetic field, okay, the EMF will be induced into that coil. See here, the lamp is glowing, means EMF will be induced into that coil. So when this coil is placed in the magnetic field, this coil is rotated. When the plane of the coil is perpendicular to that magnetic flux lines and the motion of conductor is parallel to the magnetic flux, the no EMF will be induced into that coil. So zero EMF will be induced, means there is a minimum flux cutting with a coil, so the no EMF will be induced into that coil. Now if the motion of the coil or the conductor is perpendicular to the magnetic line of force, therefore the maximum flux cutting action will be takes place, and the EMF will be induced into that coil, that is the maximum. See here, the position of coil is given. First, when the conductor motion is parallel, then the no EMF will be induced, and if the motion of conductor is perpendicular, therefore the maximum flux cutting, therefore the maximum EMF will be developed into that coil. So dynamically induced EMF, let's just, we have discussed the conductor moves in a plane which is parallel to the plane of magnetic flux, therefore does not cut any flux, hence induced EMF is zero. Then the plane of direction of motion of the conductor is perpendicular, therefore the cutting of maximum magnetic flux is a maximum, therefore the induced EMF in the conductor is a maximum. So the EMF will be induced into that coil, which is given by mathematically expressed, that is the E is equals to BLV volts. Here B is the flux density, L is the length of conductor, and V is the velocity. Okay, where we can also write the expression E is equals to BLV sin phi, where phi is the angle between plane of the flux and direction of the conductor movement. So in this lecture we have discussed about the nature of induced EMF, that is the dynamically induced EMF. In the next lecture we will go discussion on the, that is the statically induced EMF. Okay, thank you.